popularly used, right? And we did some of the numericals over there. How can we have a speed control by using the different voltage, by applying the different voltages across the armature of the DC motors. One thing you have to keep it in your mind, it should be very clear that the flux will depend upon the kind of motor which we are dealing with, right? As you could have observed that when we talk about the separately excited motor, then in that case your field flux is not going to change if we going to change the armature voltage. Will it be?
सर वो राइटिंग पैड विंडो चल गई शो नहीं।
हाँ स्क्रीन
सर विंड स्क्रीन नहीं आ रही आपकी,
एक सेकंड दो। अब आई कुछ?
यस सर।
मैं बोल रहा हूं कि ये बात आप लोगों ने नोट की होगी कि यदि हमारी जो मोटर है, सपोज इफ इट्स अ सेपरेटली एक्साइटेड मोटर, देन इन दैट केस even if we alter the terminal voltage, your field flux will not be affected by this, right? It may remain constant. It may remain constant unless we change the applied voltage, until and unless we do something over here to change this field flux, right? So this could be kept constant. So we can take this flux to be constant in case of separately excited machines. Is it clear? Whereas we have taken an example, we did that, we use those information in fact, right? Whereas if we talk about the separately excited motor which we used in the previous example, which previous numerical, you can see that in that case what will happen if we alter the armature voltage, applied voltage, then what will happen? Your field flux will going to change or not? If we vary this VT, in this case, if we vary the VT, your flux is not going to change, right? Whereas if you vary this VT, your flux will going to change or not? For DC shunt motor, बोलो। अरे हाँ ना, कुछ कोई जवाब ही नहीं दे रहा है।
It will change, sir.
It will change, ना, because the field current associated with the winding will change.
Yes, sir.
Right? With the change in this voltage, your field winding current will change, and definitely that will lead to the change in the field flux. So with the variation in VT, your flux will also vary for DC shunt motor, right? Similar will be the case for DC series motor. Similar will be the case for DC series motor. So while analyzing different motors on different voltages, keep this in your mind. If we alter the voltage over here, this is the applied voltage to the armature. So it is not only going to affect the armature voltage, but it is also going to affect the field flux, right? Okay, is this fine?
Yes, sir.
So with these observations, even you can say that, because the general expression for the torque which we have derived is the torque is equals to torque is proportional to phi into Ia, right? So we can write for this case, for separately excited motor, your torque will be proportional to Ia, because phi will be constant. Okay, because phi will be constant, so your torque will be equal to proportional to Ia. Whereas in this case, you had to write that torque will be proportional to phi into Ia for DC shunt motor. For DC series motor, you can write that this torque will be proportional to phi Ia, whereas phi is proportional to If, and here in this motor, your If is equal to Ia. This If and Ia are same. So in case of this, If is equal to Ia in case of series motor. So your torque will be proportional to Ia square. Is this fine?
Fine, sir.
Right. Okay. बोलते रहा करो कुछ ना कुछ, नहीं तो मुझे भी थोड़ा ऐसा लगेगा पता नहीं क्या हो रहा है। ओके, लेट अस स्टार्ट डिस्कसिंग अबाउट द मेथड्स ऑफ आर्मेचर वोल्टेज कंट्रोल। Right, although we have discussed it in number of times, right, in detail. So depending upon the kind of supply available, right, we have the supply AC is available. So when the supply AC is available, hello, नमस्ते भैया, अवार्ड्स कौन से हम टेक के? मैं अभी क्लास में हूँ, मैं शाम को आऊंगा तो कर दूंगा। ठीक है, so when the supply available is AC, we have one of the way is to have the one of the ways to have the control rectifiers, which we discussed. Yes or no? But we want to have the DC, we want to feed the DC motor and we are having the AC supply. What we can do is, and we want to have the armature voltage control. So what we can do is, we can use an rectifier as a power modulator in between the two. Yes or no? Yes or no?
Yes, sir.
Second option could be कि we can use a transformer with tappings, and after to that we can use a uncontrolled rectifier. This could also be one of the mechanism by which we can have the DC supply and we can have a control by with these tappings, right? The other third way which you have studied is a very conventional and old scheme of speed control, that is called as Ward-Leonard method. We can even opt this method, right, to have the speed control of DC motor when we want to have the control through armature voltage, right? Now see, if we discuss about these three, you can see that we already had classified the drives in three categories based upon the speed profiles. One which called as the constant speed drives, right? Which one will be the constant speed drive? The drive that nearly runs on the fixed speed, that runs nearly on the fixed speed is called as constant speed drive. The other classification was multi-speed drive. What were the multi-speed drives? Which drive we were calling it as multi-speed drive? Anyone of you? हाँ, कोई एक बच्चा बताए। विहान
याद नहीं सर।
बोलो बेटा, which one will be the multi-speed drive? किस ड्राइव को multi-speed drive कहा जाता है?
Sir, that can operate at multiple speeds.
And what about the variable speed?
So that it can have continuous and variable speed. Multi-speed में levels and variable में continuous but different.
Right. Basically, these are the three kind of drives which we can have based upon their speed profile, right? We may have constant speed drive, we may have multi-speed drive. So what happens to these multi-speed drives is that they are capable to operate at different speeds, but they can operate only on the discrete speeds, on the fixed discrete steps, right? Whereas
yes,
variable speed drives can operate at every speed in a certain range. and you can vary those speed steplessly, whereas in case of multi-speed drives your speed will vary in steps. Is this clear, bachcho?
Clear,
Yes,
sir.
sir.
Now see, if being fitted through a control rectifier, what kind of drive we can have from this? Multivariable or variable? Multi-speed or variable?
Variable.
Right. We can have a variable speed drive from there. Although we can have a multi-speed, but multi-speed also means variable speed also includes the multi-speed. Okay. But if we talk about the second mechanism, where we are using a transformer with tappings and having an uncontrolled rectifier before being feeding it to the motor, what kind of drive we will be having if we are going to use this one?
And multi.
Definitely we will have multi-speed.
Multi-speed.
Right? Multi-speed. Kyun? Because what we are doing is we are using a transformer that is being connected to the supply, AC supply, which is being available to us. The only thing is instead of the two terminals, we have tapped the windings on number of steps, right? And now we have connected a rectifier, that is an uncontrolled rectifier, to this one, right? We have a switch. This may be a switch, and we have connected our motor to this one. So if we are feeding a machine, if making a drive in such a way that we are using a transformer that is having number of tappings, then we may run our motor, right, on different speeds, but the number of speeds which we'll get will depend upon these tappings, right? They will be fixed as the number of tappings. Is this clear?
Yes, sir.
Yes, sir.
It is not the case that we will only have the speeds below the rated one. We can have the higher versions also, because these number of turns of the transformer will decide whether the voltage on this side is higher or the lower, right? But yes, always it will be in steps, right? Suppose your transformer input is 100 volts and the turns ratio is 500 to 1000. That means if we are using full number of turns, the voltage that will be appearing across this will be how much? 200? Yes or no?
Yes, sir.
टर्न्स दुगने हो रहे हैं. बताओ बच्चों, ये तो ट्रांसफार्मर में पढ़ा होगा कि नंबर
Yes,
ऑफ
sir.
टर्न्स जिधर ज्यादा होता है उधर वोल्टेज ज्यादा हो जाता है. तो दुगने टर्न्स मतलब दुगनी वोल्टेज, राइट? अगर फुल टर्न्स यूज कर रहे हैं, लेकिन जितने नंबर ऑफ टर्न्स हम कम करते चले जाएंगे, ये वोल्टेज उतनी कम हो जाएगी. अगर हम इस साइड की आधे टर्न्स यूज करेंगे तो दोनों टर्न्स इक्वल हो जाएंगे. दैट मींस अगर 100 वोल्ट्स की सप्लाई थी इधर, तो आउटपुट में भी 100 वोल्ट्स मिलेगा. This 100 volt is VRMS, right? This is not DC. This is the AC supply, and we also are getting over here is AC. ये तो पता है कि ट्रांसफार्मर में AC इनपुट मिलता है, आउटपुट भी AC मिलता है, right? So we can use this mechanism to have the speed control, or if we only have the certain requirements, if your load is such that it requires only the operation on fixed steps of a fixed speed of 2 or 3 variations, right? Suppose your drive wants to run, you have an application where you require a speed of 1000 rpm and 500 rpm, then you can use this one. You can use this mechanism, right? And this will be easy and cheaper, okay? But if you want to have a variable speed drive, then you had to use the control rectifiers, right? These are the more efficient drives. Now see the Ward-Leonard system. Hopefully you have learned this system in your course of electrical machines, and Ward-Leonard system or scheme. Hopefully you have learned this. Yes or no?
Yes, sir. किया था.
क्या था? अभी याद नहीं आ रहा, अभी याद आएगा. In this, what we do, we use the motor whose speed we want to control. And because we wish to control the speed of this motor, using armature voltage control. So what we do, we apply or we feed this motor armature circuit. We feed the armature circuit of this motor using a one generator. So we connect the motor armature circuit to the generator armature circuit, right? So we will be generating the voltage and we will be feeding it to the motor. Is this clear?
Yes, sir.
Now, because it's a generator, it converts the mechanical energy, right, into the electrical one. So it requires the mechanical energy. In most of the cases, AC motor is being used. One AC motor is being used as a prime mover to this generator. So your motor provides the mechanical energy to this generator, and this generator generates the EG on which this VG depends, and it feeds it to the motor. Now it's okay that it will provide the mechanical energy, but from where it will provide? It will provide from the supply available to this. If it's a 3-phase AC motor, it will be connected to the 3-phase supply, and your motor will provide the mechanical energy to the generator. Your generator will generate the energy, electrical energy, and it will feed to the motor, right? There is the simple mechanism. But to have the control over this generated voltage EG, what is being done in the field circuit of the generator? This is being fed by a controlled rectifier. Right? Input to this controlled rectifier is given from the AC supply available. Right? From the AC supply available, we feed the transformer. We feed the rectifier. So by varying the field current, we can vary this EG. As the generated EMF EG, we know it depends upon these parameters. That means by varying this field flux, we can vary this EG. Yes or no? Once your generator is being running at a constant speed, right? We haven't applied any control mechanism for this AC motor. So obviously it will be running at a fixed speed, as it is being directly connected to the supply, and supply voltage always remains constant, right? So once this remains constant, that means your generator will be running at a fixed speed. Now this N is also fixed, P is fixed, A is fixed, 60 is fixed, Z is fixed. That means the generated EMF of this generator will depend upon the flux, right? Yes, because we are feeding the field winding of this generator through the control rectifier, we can have a control over the field current, right? So by controlling this field current, we will be controlling the field flux, and from that we will be controlling the generated EMF. Obviously this generated EMF will turn into the terminal voltage of this generator, that is being connected to the motor, and it will become the terminal voltage to this motor. Is this clear? For the field circuit of the motor, we can even use an uncontrolled rectifier if wished to. Because we don't want to have the field flux control. If we don't want to have the field flux control, then we can use an uncontrolled rectifier even for this machine. Right? Is this clear, बच्चों? जो अभी तक बात बताई वो बात क्लियर है?
Yes, sir.
Yes, sir.
Yes, sir.
Right? So अगर हमें इसकी वोल्टेज कंट्रोल करनी है तो क्या करना है? केवल फील्ड करंट को चेंज करेंगे और जो अप्लाइड वोल्टेज है वो चेंज होने लगेगी. आई थिंक इट्स वेरी क्लियर, राइट? अब है क्या कि what are the disadvantages of this system? Let us talk about the disadvantage of this system. You can see that the major disadvantage of this is for controlling a speed of a motor, right? We are using two another machines. In fact, this generator should be of a equal rating to this motor, right? So to have the speed control of a motor, we are using two different other motors as well. So it comprises of three motors. So because of these combinations of three motors, the major disadvantage is that it requires initially high cost. There will be a high investment required. Yes or no?
Yes, sir.
Yes, sir.
What could be the other disadvantage if we are having the three machines where we want to have the control over the one only?
So maintenance.
Right? Maintenance required will be high. Any other?
Sir, efficiency.
Huh? Bolo, kya
Sir,
bolo?
low efficiency.
Yes. If we talk about the overall efficiency of the system, it will be low because there will be because we are using multiple machines and each machine will having their own losses. So if we talk about the total losses of the system, they will be very high. So because of that, the total efficiency of the system becomes very low, right? Low efficiency. Any other, if you are guessing, any other drawback which you can guess?
सर मल्टी स्पीड और वेरिएबल स्पीड नहीं हो सकती.
नहीं, you can have a variable speed from there.
Sir, एरिया थोड़ा ज्यादा चाहिए.
Obviously, because the setup will be bulky. This setup will be bulky. So because of that, there will be a requirement of a larger space, right?
Yes, sir.
So it requires a larger space to install, and everywhere we don't have enough space to give to the particular setup. So it becomes one of the major limitations or disadvantage associated with Ward-Leonard system. Is this clear? इसका बड़ा साइज होना एक डिसएडवांटेज की तरह है क्योंकि हर जगह हमारे पास उतनी स्पेस नहीं होती कि हम दे दें, राइट? तो इन मैनी ऑफ द एप्लीकेशंस वी रिक्वायर स्मॉलर ड्राइव्स, राइट? यू कैन टेक ऑन द एग्जांपल ऑफ शिप. बोलो क्या कह रहे हो बेटा?
कुछ नहीं सर.
कुछ तो बोला, बताओ कुछ कहना चाहते हो तो.
नो सर, कुछ नहीं बोला था.
चलो ठीक है. तो these are the disadvantages. There could be one or two more, but yes, these are the major disadvantages. But why then we are using this? Because first of all, it is providing us the way to control the speed of the DC motors, and before 1960s your DC motors were more preferred for the applications where we require the speed control, right? We were using the DC motors mainly for the applications where we require the speed control, right? Now there could be other advantage also. So in the advantage, the major advantage is that this drive possess the inherent characteristic or inherent quality of regenerative braking, right? It have inherent quality of regenerative braking. Although I haven't told you about the braking, but yes, we haven't seen the 4-quadrant operation, right? And because of this regenerative braking, it can operate in all 4-quadrant operation, on all 4 quadrants, right? Which allows, we can write that, which allows this system to operate in all see, in the 4-quadrant operation, one thing which you should note is that there should be a current reversal, right? Now see, how does the current will reverse in Watt-Leonard system? When this will be acting as a motor and this will be acting as a generator, your current will flow from here to here. Am I right? Your armature current will be flowing from here to here. This will be the direction of the current flow for the armature. Yes or no? But for our regenerative action, what we want is to reverse the current flow. Means instead of the current from right to left, we want current from right to left, right? Instead from left to right, we want the current from right to left. Now, how does we get that? How does we do that? Basically, for doing that, what we do, once your motor, let us suppose that it is being running at 1500 RPM, right? We are controlling the speed, and the final speed, let it be a 1500 RPM, right? Your motor is running at that and being connected to the load as well. Now what we want is to stop this. We want to stop this. So for stopping this, to apply the brakes, we have two methods. Either we can use a mechanical brakes, right? But we already have discussed that there are number of disadvantages associated with the mechanical brakes, right? So what we do, we usually use electrical brakes along with the mechanical brakes, right? Now, if we want to have a mechanical braking, what we had to do is we have to somehow extract the energy which is being available in this system, available in this motor load system, right? We had to extract that. For extracting that energy, basically current reversal is being required, right? Because your motor will keep on rotating, and until and unless this speed will be zero, the EMF that is being induced in this machine will not be zero, because EMF will also be proportional to the speed of this motor load system, right? So until and unless the motor speed will be zero, your armature voltage is not going to zero. So what we can do is we can use this voltage now by lowering down the VG. And how can we lower down this? Similarly, as we have increased it. So to lower down this, we can lower this current IF, and as we lower this field current, this EG, generated EMF of the generator, will be lowered down. When this will be low and this will be high, your current will start flowing from right to left, right? And your motor will become generator, whereas this will become motor. Now the energy that is being transferred from this motor to this one, from this machine to this one, where will it go? It will be transferred to this AC motor, that will transfer it to the supply. Is this fine? So in this way, your 4-quadrant operation will take place with the Watt-Leonard system. Is this clear, बच्चों? अरे हाँ ना, तो कुछ भी तो बोलो, मैं ही बोलता रहूं, बोलिए।
यस सर।
अच्छा, हाँ ना से पहले अब तुम ऐसे बोलोगे, देखो मैंने अभी एक वो पढ़ा है नोटिस, तो उसमें लिखा है कि तुम्हारा एक क्लास टेस्ट होना है ना?
Yes, sir.
What I will be doing is I will be taking the class test of all the 3 sections together. I am teaching in the 2, and one other faculty, Dr. Ankit Singh, he is being teaching in the section 1, right? I'm teaching it to the section 2 and 3. But we will be taking a combined test. And as I discussed with the section 2 students, they are more comfortable in multiple choice question and answers given through the Google form. So are you also comfortable in that, or you want to give it in the form of Viva voice?
Sir, MCQ.
MCQ sir, MCQ.
MCQ, right? तो 2 ही बच्चे MCQ से देंगे, बाकी सब Viva से देंगे।
सर MCQ
अच्छा, चलो ठीक है, ठीक लगी है ना? तो MCQ से ही टेस्ट होगा। डेट मैं आपको फाइनल कर दूंगा, राइट, कि भाई इस डेट पे होगा।
सर सिलेबस
सिलेबस भी मैं बता दूंगा, अभी मैंने क्वेश्चन पेपर बनाया नहीं है तो मैं सिलेबस बता दूंगा। होपफुली यूनिट 1 रहेगी और यूनिट 2 का कुछ पोर्शन रह सकता है ना। आप तो यूनिट 1 तो मेनली मान ही लीजिए, ठीक है।
सर सिर्फ यूनिट 1 ही रख लेना।
कोशिश कर लेते हैं।
ओके सर।
ठीक है, ठीक है, तो आगे बढ़ते हैं। हम पढ़ रहे वार्ड लियोनार्ड सिस्टम। हमने देखा कि वार्ड लियोनार्ड सिस्टम को यूज कर सकते हैं स्पीड कंट्रोल के लिए, लेकिन कुछ एप्लीकेशंस ऐसी हैं जहां पर वी मे नॉट हैव एन एसी सप्लाई अवेलेबल, राइट। Even it is hard to have the diesel, it is hard to have the DC power supply. Now, and one of the such application is the ship propulsion system. है ना, one of the such is propulsion. शिप प्रोपल्शन, राइट। तो तुम शिप पे क्या है कि एसी सप्लाई तो मिलेगी नहीं, तो उस केस में क्या किया जाए, इफ यू वांट टू हैव एन वार्ड लियोनार्ड सिस्टम, देन एज अ प्राइम मूवर वी कैन यूज अ डीजल इंजन इन प्लेस ऑफ एसी मोटर, राइट। द ओनली थिंग व्हिच विल चेंज इज that in case of AC motors which we are using and that is AC motor is being fed through the grid supply, then in that case it was possible to run that drive in the regenerative mode, because the supply, that extra energy which is being produced by the motor can be fed back to the grid, right. But in case of ship propulsion, if we are using a diesel engine, then this regenerative action could not be possible, because it will not allow to use that energy. So if we are using a ship propulsion, then we can use a diesel engine as a prime mover, and that will be connected to the generator. Your generator again will be connected to the motor to feed the voltage, armature voltage, right. Now it could come in your mind that what will happen to the field winding of the generator and the motor. So for feeding this field winding of the generator and the motor, one again a generator is being used. A generator is used to feed the tube, right. That is being coupled to this diesel engine gear only, to diesel engine shaft only, right. To have the, right, one more thing, to have the control over this field, because now supply available to us is DC, that is being generated through the DC generator. What kind of circuit we are using? We will be using chopper circuit, right. We'll be using chopper circuit.
Yes sir.
Here as well as here, if we require to have the field current control, then we can use a chopper over here. Otherwise we can directly feed the machine, we can directly feed the field winding of the motor, right. So this is the diagram, schematic diagram of a diesel engine driven Ward Leonard drive. We called it as Ward Leonard, given on the scientist name who invented this Ward Leonard drive, right. Load will be coupled to this motor. Okay, is this fine bachcho? Let us see ki suppose we want to, now we have discussed the three methods of generating the variable voltage for applying across the armature of the motor, right? If the supply available is AC. And we can even conclude that most of the efficient and the effective way to produce the armature voltage in a controlled way will be the use of controlled rectifiers if the AC supply is available, right? Can we conclude that? So let us see the controlled rectifier fed DC drives. Right? Now in the controlled rectifiers, we may have the two classifications as single phase and three phase rectifiers, whereas single phase may again be of two kinds, one which are called as fully controlled and other which are called as semi controlled or half controlled, right? So we may have single phase or three phase rectifiers, and both could be fully controlled or semi controlled, right? See how your DC drive will look if we are feeding it with a single phase fully controlled rectifier. Suppose the supply available is single phase AC and we want to have a DC motor drive, right? And we want to control its speed by controlling the armature voltage applied to it. So how will we design that? Simply, as we are having the single phase AC supply available, suppose this is the single phase AC supply, which can be represented by Vm sin omega t, right? Then what we'll do, we'll feed it to the rectifier circuit, right? We'll feed it to the rectifier circuit, and suppose we want to use a fully controlled rectifier, then 4 number of switches will be required. Right? This output of this rectifier can be given to the armature circuit of the DC motor. Suppose we are using a separately excited motor. We can feed the armature circuit directly through this rectifier. Obviously, to make this speed control a closed loop speed control, we can sense this speed using the speed sensor. After sensing the speed, we can use this information to make a drive very high performance drive by passing it information to the comparator where we have fed the reference speed. It will be compared, right? The information will be passed to the control unit, which embodies the controller, right? There will be the control algorithm and the controller, the control unit. That will generate the firing pulses for these 4 switches, right? We know that if it's a fully controlled rectifier, then the output of this in a continuous conduction mode will be equals to 2 Vm by pi cos alpha. Yes or no? This will be the output.
Yes, sir.
Right? So we can see that by varying this alpha, we can vary this V0, which is the Vt to this DC motor. And we already have developed this concept that yes, by varying the armature voltage, we can vary the speed. And your armature voltage and speed, they will be directly proportional or inversely proportional. They will be. Bolo bhai. Armature voltage or
Directly.
speed. Huh?
So directly.
Bolo, bolo. Yeah, they are directly proportional. So that means if we will increase the voltage, then your speed is going to increase. If you will decrease the voltage, your speed is going to decrease, right? So they are in direct relationship. So you can understand very easily that we can have a speed control using this system, right? Let us take one example, or let us take one numerical to understand this. Suppose the numerical is like this. A 200 volt 875 rpm and 150 ampere separately excited DC motor has an armature resistance of 0.06 ohm, right? Now they are saying that it is fed from a single phase supply fully controlled rectifier. It is fed from a single phase fully controlled rectifier with an AC source of 220 volts 50 hertz, right? They are saying that assuming continuous conduction mode that we discussed, calculate what we have to calculate. We have to calculate firing angle alpha for rated motor torque and 750 rpm of speed. Second, they want us to calculate firing angle if the torque is rated but the speed is now reversed and it is minus 500 rpm. In the third case, what they wish us to calculate motor speed. They want to calculate the motor speed when alpha is being given equals to 160 degree, and torque they are saying that it is the rated torque. Means in every case the torque that is need to be developed is the rated, right? This is the numerical. सब अपना रोल नंबर लिखो.